A list within another list is called two-dimensional list. Consider the example of different lists of countries organized by region, like in our code here. You can have a more comprehensive representation of countries by creating a 2D list of your countries. So for example, these three regions can be consolidated on a 2D list like this. I'm going to create another variable called countries, and then this will be a list, a 2D list. Our first item on our 2D list will be the Asia region, then the North America region, and lastly the Europe region. Let's clean this up right here, and there you go. Now we have represented our data earlier and then consolidated it in one single list, a 2D list called countries. Now, how do we refer to each item on our 2D list here? If you want to access specific region, you can use one index referring to the position on our list. For instance, I would like to print and access the Asia region. I'm going to use the countries variable and use index 0 to refer to that list, our Asia region list. Then we'll print out this item. So let's run our program now. Here, Philippines, Japan, and Korea were printed out since we made a reference to the first item on our 2D list using index 0. So here, index 0 will be Asia, index 1 will be North America, and index 2 will be Europe. Since 2D list is a list containing another list, if I retrieve an item here using one index, we're going to retrieve a subset of our list, similar to our example here. If we want to access a deeper item on our 2D list, in this case a specific country, we can use two indices. For instance, if you want to access Philippines only and at the whole Asia region, I'll refer to that item as this one. First index would be 0 since Asia is the first on our list, and second index would be 0 as well since Philippines is the first item on our Asia region. Now if we want to access Japan, we need to use 0 as our first index to access the Asia region, and 1 as our second index since Japan is second on our Asia list. Let's also access United States. We'll need to use countries, and then for our first index it would be 1 since North America is second on our 2D list, and then 0 as for our second index since it's the first item on our North America list. On another note, 2D list is called as such since data inside them can be visualized in tabular form. You can visualize our 2D list as a table like this. Each row representing our regions. Combine this with columns, we can reference a specific country. In our example, Philippines is in row 0 and column 0, Japan in row 0 and column 1, United States on row 1 and column 0. If we translate it to indexing, rows will be our first index and column will be our second. That's the other way of viewing 2D lists. Hopefully that helped you get a better grasp on the concept of 2D lists. Now let's run our program. Here it printed Philippines, Japan, and United States. To insert new items at a specific position, we can use the insert method and specify the index. For example, if we want to add a new region on our list and place it in second position, somewhere here in the middle of our Asia and North America region, we can do the following. Countries and our insert method here, and then we'll use index 1 since we want the second position, and then for our second argument we'll add another list. So this one will be Middle East, containing only two countries, Egypt and Israel. And then we'll also print our countries list. Oops. There you go. Let's see how our list is going to look like. Here, our new list got inserted at index 1 with North America and Europe getting pushed in higher positions. We can also specify items on our 2D list, in this case our countries, by specifying two indexes. Let's update Japan and change it to China. So we'll refer to Japan by 0 and 1 for the indexes. Then we'll update Japan to China and then print our list. Let's run our program. And Japan was changed to China. To delete items, we can use the del method and specify an index. Let's try deleting North America from our list. So I'll use the del method, and then on our 2D list, I'll just use index 1 to refer to the North America region. I'll run this now. Oops. Let me add another print statement. And we'll run this again. Here, we are left with two regions after deleting North America. You can also delete specific countries on our list by specifying two indexes on del method. This time, we'll only delete Mexico from our North America region. So I'm gonna specify a second index here to refer to Mexico. So 0, so this is our index 0, 1, and 2. And we'll run our program. This time, North America region on our list was retained, with only Mexico getting removed. Similar with 1D list, you can also iterate through 2D lists. For example, if we want to iterate through our list and process items on regional level, we'll use a simple for loop. Let me just remove these. So here we'll specify a for loop and loop through our countries list. Then we'll print each region. Let's test this now. Here we had 3 iterations since we had 3 regions on our list. Let's try iterating 2 more specific items. We'll iterate over our 2D list, but this time we'll do the processing on country level. To do this, we'll have to use a nested for loop. Inside our for loop here, we'll add another loop to iterate each item on our current region list. So let's add another for loop here. for country in region, and then we'll print each specific country. Let's run our program again. Now it's printing each country on a separate line. We had one iteration for each country on our 2D list. This is what happened on our for loop. Our outer loop here is iterating through our lists on region level, so Asia, North America, and Europe. And then for each iteration on our outer loop, there will be another for loop like here to process each item on our region list. So our first iteration on our outer loop will process the Asia region list. So here, this one will be the first iteration for the outer loop. And then our inner loop, this one, would iterate over the Asia region and process each country on this list. So Philippines, Japan, and Korea. Second iteration on the outer loop will process North America region, and then with our inner loop, it will process each country on North America. So United States, Canada, Mexico. Similar thing will be done on the next region. Creating nested lists can be useful and has multiple use cases. It should help you to process related lists better. File handling is an important part of any application. Python has several functions for creating, reading, updating, and deleting files. Let's say we have a text file named employee.txt located in the same folder as our Python directory. So let's create a text file here, employee.txt. Then we'll have two employees, John and Jean. To open the file, we'll use the built-in open function. First, I'm gonna declare a variable here, and then initialize this with open function. And then we'll refer to our employee.txt file. So open function takes two parameters, file name and mode. But when reading a text file, it's enough to specify the name of the file on our open method, because this line right here is equivalent to here, because R here is for read and T is for text. They are default values, so you don't need to specify them. Remember, open method takes two parameters, file name and mode. So our mode here is read a text file. So this one and this one are similar. There are 4 different methods for opening a file besides read, which is R here, but we'll discuss them in detail later. Basically, aside from read, the other 3 are for updating and creating files. In addition, you can specify if the file should be handled as binary or text mode. T for text mode and B for binary. We'll only deal with text file in this tutorial. Going back to our example, since the open function returns a file data type, we can print our contents of our text file using the read method. So let's do that. F, then our read method. Let's run our program. Here we got John and Jean, same as our contents in our text file. You can also choose to return only one line from your file by using the readLine method. So let's change this one to readLine. And there you go. It only printed out John, which is our first line. If you want to process your file line by line, you can use the for loop. So let's do that. So for x in f, for each iteration, we'll print out employee name is, then our employee name. Let's run our program. As you can see, we're able to process each line in our text file. To write to an existing file, you can use three different parameters. They are append, write, and create. Let's try appending to our file first. So here, we're going to remove this one. And then, in order to append to our file, we need to use the append parameter, which is a. And then, let's use the write method. And then we'll add James to our employee list. And I'm just gonna insert an escape character here so that James will be placed at the next line of our text file. And it's a good practice to always close the file when you are done with it. Simply use the close method to do so. So f.close to close our file. The reason you want to do this is because in some cases, due to buffering, changes made to a file may not show until you close the file. To validate our changes, we have to open the file again, but this time in read mode. So let me just copy this one. And I'm gonna leave it to the default values, which is read and text file. Then let's print the contents of our file and we'll run our program. So let's check first our employee.txt. Here we only have two employee names, two lines, and then we'll run our program and we'll see what happens. So here it printed out three lines, John, Jean, and James. And if we look at our text file, we now have an additional line with James. And that's it for appending to our file. Now let's try using the create or x parameter to generate a new file, employee2.txt. So we'll change this one to x, and then we're going to change this one as well, employee2.txt, so that we can create a new file. Then let's try running this one. Alright, now if we look on the left window, we can see that employee2.txt was created. This one's still an empty text file. So you can see it's blank. Now we'll also use the write parameter. We'll change this one to w, and then we'll change this one to employee.txt. We'll see what happens if we run this one and we have a file that already has contents. I'm gonna run this one. Let's see. It's now empty since it has been overwritten by the write parameter. You can also create a new file using the append parameter if the file you specified does not exist yet. To delete a file, you must import the OS module and run its remove function. Modules are just Python files containing a set of functions you want to include in your application. We'll discuss them in detail later on this video, but for now, let's just import the OS module. To do so, we have to use the import statement and then the module we want to import. Then we are going to use the remove function to delete our file. So here, remove, and then the file we want to remove, and we'll run our program now. Now, if you notice on the left side of the window, the file is now removed from our computer. We're now left with employee2.txt. To avoid getting an error, you might want to check if the file exists before you try to delete it. To check if file exists, let's use another function called path.exists to verify the existence of our file. So let's do that. We'll just remove this first. No, let's not do that. Let's add an if statement here, and then our text file employee.txt, and then if this file exists, it should remove it via remove function. Otherwise, it should go into the else block and execute a print statement saying the file does not exist. So we're expecting here that it should execute the else block since employee.txt was already deleted from our operating system. Let's see what will happen. Since we just removed our employee.txt file earlier, it printed out the file does not exist. When an error occurs, or exception, as we sometimes call it in programming, Python will normally stop and generate an error message. Ideally, you would want your programs to keep running for a long time, even if, for instance, you have some user entering some bad data. For example, we have a program here that accepts an integer as an input and prints out the squared value of that number. If we entered anything other than an integer, we're going to get an error causing our program to stop. Let's try running our program. Here, let's try to enter a non-integer input. So I'll enter a character. And we got here, Python is telling us that we got value error since it's expecting an integer data type. These exceptions can be handled using the try statement. We'll put the lines of code here inside the try block. Let's do that. So try, and then we need to indent this block. Oops. And then we're going to add an except block here. This block right here will execute the steps in response to an error in our try block. So if we got an error, it's going to print something. An exception occurred. So here we have our try block, which will be checked. If there are errors in this try block, it's going to execute all these statements inside the except block. Then let's just try to add another print statement outside our TryExcept block. Let's just say end of program. Then we'll run this one. We'll try to enter again, a non-integer input. This time it printed out an exception occurred instead of just terminating our program with an error. It managed to execute the succeeding code after our TryExcept block. So here, it still executed this statement. You can define as many exception blocks as you want. For example, if you want to execute a special block of code for a specific kind of error, let's say we want to execute something specific in response to a value error. That's the name of the error we got earlier when we tried entering a character instead of an integer. We'll add another except block on our program, but this time we'll specify value error. And then we'll add a print statement inside that block, value error exception occurred. This block of code will only be executed when we get a value error. So let's just correct this one. Oops. There we go. We'll try to run our program again. We'll enter again a non-integer input. In this run, it executed the code inside our first except block in response to value error. Now, if we get another error aside from value error, this except block will be executed instead. Let's try doing that. Let's try running our program without declaring our x variable here. So I'm just gonna comment this one out so that it won't be read or it won't be interpreted by our Python program. So here we should expect a different error. Let's try running our program. This time our second except block got executed instead, since we got a different kind of error by referring to a variable that has not been defined. Because remember, we commented out this line of code. There's also the else keyword, which you can use to define a block of code to be executed if no errors were raised. Let's just remove this comment right here. Then we'll add an else block to our program. So we'll add a print statement here saying no errors raised. Let's also add a finally block, which will be executed regardless if the try block raises an error or not. So we're going to add a print statement here saying that the try except is completed. Then we'll run our program. We'll enter an integer. Here it executed the else block since we have a valid input. No errors raised. Afterwards, it executed the finally block, this one. So it printed out the TryExcept is completed. Then finally, the print statement outside our TryExcept, which is this one, end of program. Let's also try entering an invalid output or invalid input as well. So here I'm gonna enter a non-integer input. It executed our except block, value error, exception occurred, so this one. And it executed as well the finally block, regardless. So here, the TryExcept is completed. If you ever come across the term Object-Oriented Programming Language, or OOP for short, Then classes are what makes Python an OOP. Classes are essentially a template to create your objects. Objects are encapsulation of variables and functions into a single entity. To create a class, use the keyword class. For example, if we want to create a person class, we'll type in class and then person. When creating classes, you can think of it as logically creating your own custom data type with native data types as your basis. Then, we'll use the init function to initialize the values of our person class attributes. So, we'll define the init function. So, it starts with the double underscore and ends with double underscore as well. We'll use the init function to initialize the values of our person class attribute. All classes have the function init, which is always executed when the object is being created. Since all persons have name and age, we'll designate them as our person class properties. So we'll add here name and age. The self parameter here is a reference to the current instance of the class and is used to access variables that belongs to the class. It does not have to be named self. You can call it whatever you like, but it has to be the first parameter of any function in the class. If an instance of this person class is created, in order to initialize the variables of the current instance, we have to do this. Self, then our attribute, name. Then we'll assign the name parameter. Then our attribute, age. And we'll assign age as the parameter. So here we are assigning the name and age parameters as values to this person's attribute when an instance of this class is created. To create an instance of this class, we'll do the following on our main block. So here, I'm creating p1 variable and then person. Then we'll pass John as our name, and then 28 will be the age attribute. Here we're creating an instance of the person class. We're assigning values John and 28 to this instance properties. This p1 variable is a reference to the person instance that we've created. By the way, you can think of an object as an instance of a specific class. So you might notice that I'm using instance and object term interchangeably, which is fine. Going back, after creating our instance, we can make a reference to the properties of this person instance. Let's try printing out the properties of our instance here. So we'll do p1, then the name, attribute, and then we'll also print the age attribute of our instance here. Let's run our program. Here we've printed out the attributes of our p1 instance, John for the name and 28 for the age. Similar to how strings have built-in methods, objects can also contain methods. We'll create a method in our person class that prints out a greeting using the name and age attributes. Let's do that. We'll define a function named greeting, and then we'll execute a print statement. Hello, my name is, then concatenate our name attribute as well as our age attribute. Then we'll have to call our greeting method here on our main block. Let's try running our program. Here it printed out, hello, my name is John. Then the age attribute by using the greeting method we just created. You can also modify properties of objects after initializing them. So here, let's try increasing John's age to 40. And then we'll print out the updated age attribute. Here, the age is now 40 after doing an update. Let's also try creating another instance of our person type. Let's say we have another person, so we'll refer to that person as for P2 variable, and then that person's name would be James, and he will be 30 years old. Then let's just execute the greeting method for that person. There you go. So it printed out, hello, my name is James, then 30 for his age. With your class created, you can also use them on your future Python programs. We'll create another Python program that can make use of the person class we just created. First, we're gonna create another Python file. Let's name this one as app2. Then to make use of the person class, we'll use the import statement. So import and then our app module. Remember, a module simply refers to another Python program file. Here we are importing app as a module. So this one. Let's go back here and let's just clean out the main block. The usual practice is when creating a class, place it in a separate Python file without placing anything on its main block. After that, we'll create a person instance in app2 program. So here we have P1, and then this time we need to reference our module app. Then we'll reuse the name John, and age will be 36. Let's also call the greeting function. To make our references to our module shorter, we can use an alias instead. We'll use the as keyword and assign PR as the alias. We can then use this alias instead when referring to our person instance. Here we'll change this one to PR, our alias. Then let's try running our program to check if this one would work. So let's run, then our app2 program. So here we can see that the alias is working in our app2 program, and we've successfully imported the app module in this program. You can also import specific functions only from a module. Although we only have the definition of person class on our module, so here, the benefit of doing this is that we don't have to specify the module name or alias when referring to the person class. Let's try doing that. So we'll change this one to from, app, and then we'll only specify person for importing. Then with these, since we've imported person class specifically, we don't need to specify these alias. So here it's not showing any red lines in our code, right? So this is syntax correct in terms of syntax. These are just another example of using a module. There are several built-in modules in Python, like the OS module we used earlier in our previous lesson. We imported the OS module to do some file handling earlier. Inheritance allows us to define a class that inherits all the methods and properties from another class. For instance, we want to create another class named student. Like person, a student has a name and age. But a student can also have other properties like course and graduation year. In our case, instead of defining again the same properties and methods as our person class right here, and then defining it in our student class, we can inherit all of these one in our student class. This will also show that there's a relationship between these two classes. The student class would be the child class, while person class will be the parent child. So here, let's create class, then student, and then we'll make a reference to our person class right here. So here what we're doing is that we're creating student as a child class, then we imported the person class as our module, then we specified person inside the parentheses of our class statement. We'll have our init function here. So def init, then self, and then we'll have our name, age attributes, but we'll add two additional properties. Let's call them course and then year. If you want your child class to have the same exact properties as your parent class, you don't have to define an init function. We're just doing this since we want additional properties besides the one from our person class. We'll use the super function and then init name age. So we'll use the super function here, so we do not have to use the name of the parent element. It will automatically inherit the methods and properties from its parents. Then we'll set our new properties, grad year and course. Let's do that. Course is equal to our course parameter. Grad is equal to our year parameter. Here we've set our new properties, grad year and course, and assign it to the value of our course and year parameter. We can add a new method to our student class that will call greeting function and print out the student related details. So let's call that new function or method as intro, and then we'll call our greeting method inherited from the person class, and then let's add a print statement here saying I graduated on, then let's append our grad attribute or grade, no, let's call this grad for graduation. And then with a degree on, then we'll append our course attribute here. And then on our main block, let's create an instance of a student. Let's use John again as an example. 28 for the age. His course will be CS or computer science. Then he will graduate on 2013. We'll also call our intro method here. Let's run our program. Alright, so here we can see that our intro method that we just created is working just fine. So it was able to use the greeting method it inherited from the person class. So it printed out, hello, my name is John, 28, and then it also printed out this statement, I graduated on 2013 with a degree on CS. To recap, we've learned how to use 2D lists to create a more comprehensive representation of our data. We also learned how file handling works in Python. Then we learned how to keep our programs running by handling errors through the use of TryExcept statements. We also learned how to make use of other Python programs by using them as modules. Lastly, we learned how to create classes and inheritance to encapsulate our data.